Hey, this is Presh Talwalkar reminding you to mind your decisions. What is the value of the following series? The first term is 1 all over 1 plus the square root of 2. The next term is 1 over the quantity square root of 2 plus square root of 3. The next term is 1 over the square root of 3 plus the square root of 4, and this continues until we have 1 over the square root of 2016 plus the square root of 2017. You have to solve this in 5 minutes and you cannot use a calculator. This problem was given to 14-year-olds in Hong Kong, and I thank Yale for suggesting it. Pause the video if you'd like to give it a try, and when you're ready, keep watching to learn how to solve this problem. We're going to solve this problem using a useful formula called the difference of squares. Here's why this formula is true. Start out with one square with an area of a squared and another square with an area of b squared. If we subtract the area of b squared from a squared, we have the following shape. We can now dissect this shape into different rectangles and we'll connect sides of equal length. The a minus b sides will connect together. The resulting shape is a rectangle where one side is a plus b and the other side is a minus b. Thus we have the formula a squared minus b squared is equal to a plus b multiplied by a minus b. So how does it help us solve this problem? We'll take a look at the series. The very first term can be rewritten as 1 over the square root of 1 plus the square root of 2. So a general term in the series will be 1 over the square root of k plus the square root of k plus 1. Let's analyze this term. First, I'll flip the two terms in the denominator. Now, we'll multiply both the numerator and denominator by the square root of k plus 1 minus the square root of k. If we multiply both the numerator and denominator, it's the same thing as multiplying by 1. The numerator will simplify to be the square root of k plus 1 minus the square root of k. Now the denominator will be a difference of squares. Here we have a plus b, and here we have a minus b. Thus the result will be a squared minus b squared, which simplifies to be k plus 1 minus k. The terms k will cancel out, and we're just left with 1. Thus we have the square root of k plus 1 minus the square root of k. Now this term, which is equal to 1, just vanishes, and so we simplify our formula like this. We're going to flip the terms because it'll be a little bit easier down the line. Now, let's take a look at our series and we'll substitute in. For the first term, we're going to end up with negative square root of 1 plus the square root of 2. The next term will be negative square root of 2 plus the square root of 3. This pattern will continue and we keep substituting. What's the point of all this? Well, we're going to get a magical simplification. Notice this square root of 2 minus square root of 2 will cancel out. Then the square root of 3 minus square root of 3 will cancel out, and so on. And each of these terms will cancel out. The pattern is reminiscent of a telescope, and thus this is known as a telescoping series. When you retract the telescope, only the beginning and the end remain. Similarly, in this series, it'll contract to just the first term and the very last term. And so, we simplify once more. Negative square root of 1 will be equal to negative 1, and then we flip the terms. And that's our answer. This series simplifies to be equal to the square root of 2017 minus 1. Amazing! Thanks for watching and for making Mind Your Decisions one of the best channels on YouTube. Thanks for watching and thanks for your support.